Mi sentite? Qualcosa? Ok. Sì. Allora. Ok. Okay. So, welcome to this presentation for Team Diana Recruitment 2021. I am Leonardo Festa, team leader and chief engineer of Team Diana, and I'm very glad to see all of you here. So, Team Diana is a student team involved in space robotics since 2008, and the name is a Latin acronym that was made by the first professor of the team, Genta, and is Ducti, Ingenio, Accipimus, Naturam, Astronum. That means something like driven by intellect, we understand the nature of stars. And okay, this is the one of the first photo taken by the team. And so we started as a part of Team Italia in order to participate to the Google Lunar X Prize in the old times. And at that time, the Politecnico participated through Diana at this competition, and we was in charge of the rover, while the other part of the Team Italia was other university that take care of other aspects of the mission, like the lander and so on. And this is the first rover of the team, Amalia. And it's a small lunar scout equipped with just a stereo camera for mapping and capturing images of the moon soil. The project was actually space grade, and it has been a good chance for the team to gain some patent and also some publication, for example, in the wheel and in the system of mobility adapting to the soil. And then, once Google Lunar X Prize was over, the team started working towards a new target, which is Mars. And in 2016, we start working on Toro, T0R0 actually, a Martian rover equipped with a 6 degrees of freedom arm and 6-wheel with a rocker bookie architecture and slip steering technique for the steering. The design and production process lasted almost 3 years and involved between 100 and 150 students. And at last, this rover was presented in European Rover Challenge 2018 in Poland, in Starakowice. Then, after this competition, we felt the necessity to develop a better architecture for the locomotion system, and we switched from slip steering to steering wheels with the rover Trinity. And the project took just a year and was presented to ERC, European Rover Challenge 2019, in which the rover proved to have some problems that we tried to solve with the next version, which is actually the rover you can see here, Ardito. Okay, sorry. So while we getting back from Poland, we started developing the next rover, which is Ardito. And but in a few weeks, we understood that it was not a minor improvement to Trinity, so we changed name and we started Project Ardito, and is still under developing. So we already have a good platform, which is not fully mounted here, but we'll continue to work on it until we feel the necessity of a new rover. And so this is a brief history of the team, and I just want to spend a few words on our internal structure. And the team is divided into groups of work that are mostly arranged into departments. Right now we have a mechanical department, an electronic department, a computer science department, and a management department. Outside of this subdivision, there are the scientific group and the media and design group, which are not like, I don't know if you can read clearly, but it's not so so important. It's just the figure, the scheme. And my colleagues will talk more about the various department and groups work. And now I leave the word to Alessandro Meloni, which is our project manager.
Hi. So, as Leonardo said, I'm Alessandro Meloni, and I'm the project manager of the team and of the project. Okay, and I'll talk about the competitions and the events that we usually take part in, and we focus and we base our research, let's say. So, mainly at the moment we are focusing on the Rover Challenge Series competitions. Some of the photos that you've seen before are from our past experience in the European Rover Challenge, where we attended during 2018, 2019 and 2020. And together with all these other competitions, like the University Rover Challenge that is held in the United States, the Canadian one, the Indian one, and another sub-part of the Indian Rover Challenge. They are meant as like competitions between university teams for testing several prototypes in different kind of scenarios that are likely to happen in a human exploration of a planet, namely Mars. So these kind of tasks revolve like the navigation of an unknown environment, using like autonomous navigation mainly, somehow helped with air tags or like recognition of features for localization. There is then maintenance or servicing operations that meant to operate on a panel and like supports what might be needed to control and keep the operating status of moon bases, of bases and other equipment. Then there's also like science analysis that's meant to analyze the environment, grant data about the environment, the soil, and there are several kind of research areas, like also identifying life, if it's present, if it was present, and stuff like that. And then there's like the collection retrieving tasks that is meant to collect objects from the ground, important objects, or also like leave objects on the ground for hypothetical sample return missions, that objects, samples that can be then retrieved by others and sent to Earth, where they can be measured more appropriately, let's say. Then at the moment we are also taking part in a particular challenge that is different from the ones before, and it's the ESA Space Resources Challenge. This one is like promoted by ESA, the European Space Agency, and is meant to like further the development of several prototypes that hopefully will be sent to the moon for a real space mission in the future. And as part of these competitions, we are participating together with other teams of Politecnico within the project of Polito Moon, where we'll demonstrate our system this November in the Netherlands at the Hashtag Space Center. And so these are like the main, the core activities, the core events that guide the development of our projects and the system and the technical development in general of the team. But we also take part in several other public events for like promoting activities, also like promoting the image of the team and of the Politecnico. And like some of them are the European Researchers Night, that are like an event for promoting science research. There is also fairs and expositions like the automation in testing that held together with other companies involved in the robotics sector. And then also like other events. There is a photo with Paolo Nespoli, the astronaut, when he was like when he graduated from Politecnico some years ago. And yeah, several also events promoted by Politecnico to spread the information about university research, etc. And so yeah, this is the several public events we've taken part in. And is a little summary of the projects said by Leonardo before. Mainly we have like Amalia, the first one, Toro, Trinity, and now we have Ardito. We are still working on a logo. That's why we need media and design people too. And yeah, so now I'll leave the word to the other members of the team to explain in details what the technical part is.
Thank you. Hi everybody, we are Lorenzo, Gloria and Amalia, and we are the leaders of the mechanical department. The mechanical department is one of the most numerous in the team. Sorry. Okay. Okay. And it mainly welcome students from aerospace and mechanical engineering, but over the years, even geotechnical, civil, and biomedical engineer joined the team and have been active members. So everybody interested in robotics and coming from industrial engineer is welcome to join. Okay, now it's time to talk about our last project, the rover Ardito. Ardito is a robotic platform designed to be modular, so that it can be adapted to various mission scenarios and future applications. Ardito, the locomotion structure is a rocker bogie mobility system equipped with 6 driven wheels, 4 of which are steering. The wheels are made of spring steel, so that it can be adapted to irregular terrain and absorb vibrations. And this is a graphic that explain an analysis of the movement of the wheels. And now Gloria continues with the presentation.
Thank you. Okay, now let's talk about some subsystems, some mechanical subsystems. There is the differential system that you can see with the 3 bevel gears. It is placed under the chassis, and it is the connection between the 2 mobilities. Then there is the 6 degrees of freedom arm that you can see there, and it is able to go high in a high position and in a low position close to the ground. And you can see here are shown the 6 degrees of freedom. 2 of them are on the arm base, 1 is on the elbow, and 3 of them are on the 3-axis wrist that you can see here closer. And on the top of the arm, we have the end effector. The end effector is the end of our rover. We use it for the maintenance tasks, and it is shown here. You can see, of course, about there. And it is designed to be modular. it means that we can change, for example, the fingertips basing on our needings. And yeah, you can see a CAD of one of them with the probes in the image on the left. Ardito, you can. Ardito is conceived to carry extra payloads. So, for example, we have the core driller. It is a deep sampling system for the terrain. And here you can see also the power and logic modules casing, which is this one that you can see. Yeah, now let's talk about the project phases. Yeah, basically at the start we do, of course, a kind of a brainstorming, and then we start with the part of the design. We use SolidWorks as main software for the CAD design. So yeah, we do the modeling, the design, and research, and then you can see also a render of made with SolidWorks of the whole rover. Then, for example, yeah, there are cuts of the steering brackets, and yeah, you can move on. Then the second part is the analysis. Of course, we have to validate the systems, so we use mainly MSC, Apex, Patran Nastran, and Adams. We make structural and dynamic analysis. For example, here you can see a topological optimization and model validation about the steering brackets, and then a validation with structural analysis made with FEM analysis in Apex. And then you can see also multi-body analysis, which is made with Adams. This one is for the mobility. Now Lorenzo will talk about the production phase, that is the last phase.
Hi, I work in the production phase, and in this phase we need to product these 2D CAD sheets, and communication with the company help to the management department. And the other phase is the assembly. Here are some photos of the last year assembly phase. And after that there is a testing phase, which in which we communicate with informatics and electronics to verify if everything works. And now electronics.
So, wait. Good evening, guys. I'm Edoardo Vacchetto. I'm the lead of the electronics department. Okay, perfect. And I'm also the deputy chief engineer of the team. Okay, I want to start with this very painful image of this poor component soldered to the board with this very tiny piece of very tiny wire. So, okay, perfect. So, in our department, we do a lot of things. So, starting from the hardware development of circuit, using piece of paper and hand, and after some software like KiCad, because it's an open source software. And then we develop the PCB. And we create and we produce the whole hardware. Okay, so here you can see a schematics of a very simple PCB that we developed the last year for LED that will be mounted on the 4 wheels to show the status of the rover. Then after the project on a software or on a piece of paper, we have to validate our circuit. So using simulation, or also with some hand calculation and calculator, something like that. So this is a little pic of LT Spice, software commonly used in our team. Then the very important part is the PCB production, because we produce everything starting from the project and then to soldering everything. So buying the component, so we have to speak with companies to ask about quotation and things like that. And after that, the very important and difficult part is to mount everything. So for this reason, it's very important to know how to solder at least a true-hole component or very stupid things like that. Okay, but we will teach these things if you will be in our department. And so in this image you see on the left, yes, the PCB of the LED board, and on the right the power distribution unit. I think the best board we ever developed, because it's a 4-layer PCB, and it will manage the whole power of the actuator on the rover. So if we have a fault, for example, on the steering system, or on the steering system, we can detach the motor and continue to work and do some other things. Okay? So if you have questions, sorry guys, you can stop me in every moment. Okay? Okay. Okay, pure. So the other things we have to manage are the firmware. The most important part, I think, because it's like the soul of our board. Okay, so we use STM32 microcontrollers because ST Microelectronics it's our sponsor. And for example, you can see on the left a little not very little, but a small microcontroller that we use on the steering system, for example, and on the arm. Then on the right there is the H7, a very powerful board, and in our rover this board have the controller, the mobility controller inside, and manage the whole system, the whole mobility system. Okay, so the steering, the propulsion, and the telemetry and things like that. Okay. And this board is also used on the arm, not now. So now it's a homemade board. Sorry, it's an homemade board, very beautiful but homemade board. And we will substitute it with an H7 like this one that it's very powerful. Okay, so in the end, but it's one of the most important things. You can see this part here, yes, because it's very new, like yesterday it was mounted. So it's the cable management. You can see also the quantity of cable we have on the rover, and we have in each module. So for this reason we have to manage very well this part in order to don't have free wire everywhere. Okay, so this piece you can see on the screen, it's called junction box, and it will connect the power and the logic module. Okay, from the front to the rear part of the rover, and on the top part you can see the connectors for the mobility and so on. Okay, so for these things we use also a little, no it's not little, a program inside SolidWorks called SolidWorks Electrical, and yeah, it's used to draw some electric schematics and then to create some sheets useful for data sheet and so on. So this is a little very synthetic schematic of the whole electronics inside the rover. Below there is the power part, so the line represents the power, and on the upper part there is the signal part. So for example, arm, mobility, and on the right the board inside the logic module. Okay, for example, the Jetson that is the main onboard computer. Yeah, this is everything. Yeah, there is another slide. Yes. Okay. So this is a little description of what we have to do in the next month, and yeah, in the next month about hardware, firmware, and cable. We have to solder a lot of things. We have to write a lot of code, as you can see from this slide. I don't want to read everything. And we also have to connect again the wall, everything on the rover. So to connect the power to the batteries and the logic, for example, to the arm and so on. So if you are interested in these things inside the electronics group, you are welcome, and we will be very happy to work with you. So bye bye.
Okay. Hi everybody, I am Thomas Galliano. I am a student here in Politecnico di Torino. I study computer science, and I am the lead of the department for computer science department here in Team Diana. So talking about our department, so what is our mission? Our mission here is really simple as computer scientists, is we have to make the rover move as autonomously as possible. In reality, not move, but make the rover as autonomous as possible. We do this by many ways. I think the most important one is by working on layers of abstraction. That means that I will make you an example to be more clear. We don't make our code to be like big and monolithic. We work on layers. So for making an example, a really low layer of abstraction could be take the rover and say to the rover, okay, rover, now take the left wheel, make it move, and then make it go, and then stop it. Going on, a second layer of abstraction could be to say to the rover, okay, rover, go from here to there in a straight line. Okay, so that layer will use the below level of abstraction, and so on. Okay. We do also, we keep in mind other things. We try to make our software to be the most robust and functional as possible, but also really modular, so we can in some way use it and reuse it in the future. Okay. Prego. So this is what we use here in Team Diana as a computer scientist. As you can see, we work mostly on C++. I would say that the 80% of our code is written on C++. We chose this and not C or Python or Java, which are programming languages that we learn here in Politecnico for a design choice, principally. We think it's no, because it gives us the possibility to make object-oriented programmation, but without being heavy as other languages. Or we use CMake, which is a layer of abstraction more than make files, okay, for handling the building of the software. So C++ and CMake equals C-Lion, which is the software that we actually use. Someone here is not agreeing. Then we work a lot with GitHub. The most of our code is not in our computer. Well, it is, but like it is not stored there. It is stored in repositories that we try to manage in a like a sane way, I would say. And we rely a lot on Git flow for our developing. Our ecosystem is principally based on Linux. This also is a design choice, I think most of all because our main computer is based on Linux. Our main computer is the one you can see there, which I will talk a little about to you. But the cool thing to know about it is that it's mounting a version of Ubuntu like modified and adapted by NVIDIA, which is a really cool feature. We also use CUDA and develop with CUDA. We handle communication with MQTT, which I will talk about to you later if there is some more time. And for controlling the rover, we use JavaScript because we control our rover with a really, really fine web app, which is not used to accede to teamdiana.com, but to accede to the rover and command it. If you want, after the presentation, I will show you something. I will be somewhere with the computer. I can show it to you. Also, our sub-department, which are mechatronics, they use MATLAB Simulink and to make their analysis. Then Gabriella will talk a little more about it, and the Coppelia Sim for the simulations. So yes, this is just to make you see the cool toys we play with. The base station computer is actually the computer that stays on the base station on the laboratory. When we work on the rover, we develop the code on it, we make analysis and stuff like that, but we also take the base station computer to the competitions, and so is the main instrument we use to control our rover. And yes, I will not spend too much time talking about the network, but also the network, the internal network of the rover is handled in, we try to handle it in a professional way. Let's say it like that. And yes, as you can see by the specific, it's a really good computer. Oh yes, also, just because maybe there is something, someone of you that is interested in machine learning, stuff like that, we will start actually doing it, and we will use this computer to make our analysis and yes. Okay, so yes, I just showed you the Jackson Xavier. This is our board computer. It is the brain of the rover, and yes, it is cool because it is really powerful. As I don't know if you can see it, but yeah, it is really powerful, and it is really powerful on the graphical part. Okay, on the GPU part. This can allow us to make on board a lot of complex and parallel computations, which is a thing that cannot be done with other devices like that. Okay, so this is our other little devices that we use. The Jetson Nano is the little brother of the Jackson Xavier. Okay, and we use it for the scientific part of our missions, and we use also one as a backup in case something bad happens to the Jackson Xavier, which happened. But yes, it's a reliable backup because it's the same ecosystem of our main computer. And also we use the Z2 stereo camera that I will show it to you then if you like, which is a way to we can use to map the surroundings and make analysis. Okay, so I will be quick. This, if for the ones of you that will enter in the team this year, this is our software version that you will find. Okay, it's called the Diana Software 0.5. We don't have a code name yet, and you can see the software that we currently developed. This is what we developed actually last year. So you can see there are the controllers for the arm and the wheels. So I was talking before about the layer of mi sono dimenticato come si dice, of the layer, okay, of the first layer thing. And yes, then we built some libraries for C++ to handle MQTT message and shared memory, so we are able to switch and pass big files inside the RAM. Streaming video and also the web app, which is external as to the rover. And this is the future. So for the ones of us that will enter this year, this are some of the application that we will probably work on. So stuff like position controlling, doing the path planning, moving autonomously the arm and the mobility, making the recognition of objects using OpenCV or machine learning. And yes, and more. The cool stuff about this is that there is nothing really planned. It is one of our jobs, since we are engineers, to make these plans in the future. Oh yes. So now I will pass the microphone to Gabriella, who is gonna talk a little more about the mechatronics part.
Hi, I'm part of the mechatronics side of the team, as said, and which is more or less the conjunction between the mechanical and the computer science part. And we have the code that, with a model-based approach, makes the controllers of the mobility and the arm. The latter is controlled both in direct and inverse kinematics. The models have been designed on Simulink, that is a product of MATLAB, and then code generated in C to be integrated on a Nucleo H7. About the mobility, we take as input the desired speed and steering angles of the rover, and the controller takes care of calculating the necessary steering angles and of the wheels, and power to be supplied to the motors. The control feedback is done thanks to the data received from encoders placed on each wheel and on the rocker bogie that supports them. Also, thanks to such data, we are working on the management of possible singularities, for example, boogie lock, that can occur when overcoming steep climbs. For the arm, similarly, we decide a position and orientation we want for the hand, and we calculate the necessary displacement of each joint. Or vice versa, we can control each joint individually. Again, the feedback is received from the encoders located on each arm joint. As said by Thomas, before testing it on the physical rover, it was tested on a virtual one that was built on a platform called Coppelia Sim. And here the rover is controlled with all the tools that will interact with the finished product, also a web app. And with that said, I give back the floor to the computer science lead.
Okay, so really quickly, these are the skills that we are looking for as the computer science department. Yes, I will not make the list, so you can make a photo or make a screenshot if you're following from home. So the thing is, we are looking for these skills, but don't get scared if you don't have any of them. It is totally normal, since we are all students. And so, I think the most important skill that we are looking for is the curiosity and the willingfulness to to learn about this stuff, and also to research about this stuff, because here we are constantly making research and new discoveries every day. And yes, so with this I will lend the microphone to O.
Thank you. Hi everyone, my name is Christian. I'm the leader of the management department, which is probably the least technical of all the departments and group inside the team. And our role is mostly of support to all the other departments. One of our main roles will be to support our project manager to monitor the progress of the overall project while working together with all the departments and monitoring the progress of the development of every single subsystem. Another important task that we have to do are the technical analysis. In particular is the requirement analysis, which is basically trying to understand which are the characteristics which that our rover needs the most. And particularly this analysis will be done after the rules of the competitions of the, for example, the European Rover Challenge will be out to the public. And the other technical analysis that we have to do is the risk analysis, which is, to put it simply, trying to understand what could go wrong over the months of work. For example, last year, as many of you know, the Suez Canal basically was blocked by a ship. And this event affected us, and some parts of our rovers came here late for the competition. The risk analysis is quite simple. It's a 4 steps iterative process, which are the identifications of all the risks, of all the problems that could occur while working. After that, we have to evaluate this risk, trying to understand how much probable are they to occur, and if they occur, how much damages could bring us. After that, we try to find ways to mitigate them, making big problems little smaller problems. And in the end, if they are not probable to happen, and if they are not so severe, we can accept them and go on with the rest. Other than that, we would like to improve the quality of our market research, since it's an important chapter required in all the reports that we have to submit for the competitions, which is basically trying to find out some commercial applications for the rover or for part of it. For example, the scientific department has some really cool subsystems. Both the technical analysis and the market research, as I said, are part of our reports, which are surely quite boring to do. However, they are fundamental for our team, since the qualification to the challenges and to the competitions, in particular since the pandemic, are based on the quality of this report. Another task that we have to fulfill is the management of the fund of the team. Particularly, we manage all the reimbursements, since some stuff are bought by the students. For example, you go to the shop and you buy some screws and a screwdriver, then the Polytechnico will reimburse you that amount. And other than that, in January, we will ask the Polytechnico for funds to continue with our projects, since we need money, unfortunately. And regarding the software that we utilize, they are mostly Excel, in particular for the management of the funds of the team. We use LaTeX for the drafting of the reports, since we hate Word and we hate ourselves, I guess. We also use Microsoft Project for the Gantt chart. And Valispace is a software that it's probably the least famous among these, but it's used by a lot of space agencies, both in Europe and America. And the last one is ClickUp, which is mostly used for project management stuff. What we look in people for the management department are mostly soft skills, since there is nothing too technical that you have to know before entering our department. So we look for people who are autonomous, who can work alone, even if not guided by someone else. However, in the first months in particular, we will try to follow you, to teach you what you have to do and all the process that you have to know inside the team. Other than that, of course, you have to be able to work in team, since there's never anything that you do alone. You have always to work with other people. And of course, since we are a team based on space stuff, you have to be a curious person. Last thing, you don't have to be a management engineering student to join us. Everyone is welcome from all backgrounds. And I guess that's all. I'll leave the word to Roberta for the scientific group now.
I'm not Roberta. Okay, can you hear me? Yeah, everything's fine. Okay. So I'm Marco, and she is Margherita, and we are two students who are studying aerospace engineering, and we are gonna talk about the science department and the research group. And so you are asking, why are we presenting the science if we are engineers? I don't know. They told us a bit. Okay, so no, the thing is, what is the scientific department? And okay, so the science department is a small group inside the Diana team, which focuses mostly on the scientific aspect of the competition. And as it was said before, we take part in several competitions, and each of them requires different things. So we have to focus more on some aspect of the scientific of the science for one of them, and other aspect for the others. For example, the ERC challenge ask us to do more biological research on the Mars soil, whether the Indian ones and the URC focuses more on the life detection and biology. So if we can actually find life in Mars, and so all the systems that are useful to it. And for this reason, we have to develop different subsystems simultaneously that are capable of fulfill different requirements and purposes. So how we do this? We need different kind of engineers. So physics, biomedical, management, and everyone else is really welcomed. And how we do this? We use the classical approach, so the scientific methods. We face the problem, we define the requirements, and think of a solution, doing kind of brainstorming with research, and then find a way to create a first prototype and do tests on it in order to say, okay, it's fine, or no, we have to rethink it all. And once we understand the path to follow, we start doing prototypes and go away with it. This group is very important because actually gives the line to the other groups, because for example, me and Margherita last year were part of the life detection module. So the physical things that actually do scientific research on the rover, and we needed as soon as possible all the requirements from the scientific department. So it must define what we want to do and how to do it, and then we start thinking about it and realize something that can do this. Okay, so yes, talking a bit about the history of the scientific department. The first biological big project was this one that we presented on the Indian Design Rover Challenge, and it was really good. It is composed by some boxes, filtering system, dye staining, and an automatic microscope. And it was pretty complex and well thought because it also won the innovation awards. So it was we won these awards, particular awards, because it was a good idea, a good design. And yeah, how it works, I will spend some words explaining the dye staining, because they told me to do this. So the dye staining procedure is a procedure in which the sample is dyed, so colorato, with some dye, which in this case we use the trypan blue one, and which allows us to actually see if there are bacteria in our soil that we remove from the ground, and also it can give us information about if the bacteria are alive or dead. And for this reason, it's very important to do this thing. And yeah, I will now pass the microphone to Margherita.
Well, so this year we the previous year we evolved and changed our approach. Last year we created bacteria centrifuge, which you can see in the here, and it is our past prototype that spins at 3000 RPM with soil in it. And the idea is to separate bacteria from the soil in order to with the G-force, and it gets dye stain and placed below an automatic microscope that stream the images from the chassis. And here that is a structure to move the microscope that was developed by a former member of the team, Pietro Vigliardi. And it is particularly important because otherwise it is impossible to see through the microscope. It is in fact this structure move the microscope glass and place the slide cover on it. Then a parallel project that you can see is a portable and low-cost Raman spectrometer, and I won't go into detail about it because it is still in development, but we will work this year on it. And this Raman will analyze the soil composition and biological content and more without the necessity to store the soil inside the rover. And this is a big step forward. And probably if you join the scientific department, you will work on it because it's still in development. So the next steps are to improve what we already have, and the optometry for the Raman, and sterilization of the centrifuge system, and work on sensors and other stuff. So if you are interested in these things, you are welcome to join. And what's next? Yes.
media and design.
So, sup guys, Roberta for real this time. I selected the representative of the MED group, meaning Media and Design. And this group is a brand new group, which was born this year, in order to give, next slide, a visual identity to our team. In fact, we need to consolidate the team image through logos and posters and most of all, to support the team during the competitions, because we need to create videos that will be judged by juries, and sorry, also to interact with by joining this group, you will interact with students with different backgrounds, and it will be required for you to have a little bit a creative side, a med side, and next slide. And in fact, we are looking for designers, graphic designers, cinema and media engineers, because mostly we work for the competition because we need to represent the rover for them. But we also need copywriters, storytellers, social media experts to improve our website, for example. And we need to give our rover a more human aspect, to say so. And so this is a very brief introduction and explaining all our team, but we really look forward to meet creative and crazy people to have fun with and to work with. So thank you. Bye.
Okay, so I want to thank you for being here. And so the recruitment for Diana are open, and we look for dynamic, resourceful, and passionate team players for our team. And just for for us to better understand, how many of you are from aerospace engineer? Okay, I was guessing. How many from computer science? Okay. Okay. How many electronics? Oh, okay, some electronics is still alive inside Politecnico. Someone from mechanics? Okay. Management? Alzala. Management? Okay. Guess who's been recruited? Okay, so this was a long presentation, but as you can see, the team is quite huge, and there was also some people on YouTube, and the video will be available for someone who want to look some part. And so we can have a question time / you can see the rover, you can ask us some questions. So maybe if you have some big question, we can keep the live on YouTube alive. Otherwise, we can shut it down and just have an informal question and answer time. So, any question? Anything related to the presentation or to the team? Okay, sorry. Wait.
We can use the technology.
Okay, I just wanted to know if there is any way to see a small section of the C++ program, because I'm a mechanical engineer, but last year I studied C++. So I just want to see if I maybe have the level to maybe work on that aspect.
Okay, maybe if you can remain a little bit more, Thomas, you can talk with Thomas and see like the. But I think that if you're willing to learn and to help in this in the computer science area, I think that any level is okay for starting. Then you can learn while working on in the team. And okay, just one thing I forgot. The recruitment form will be sent in the next days, probably on email from No Reply Polito, and also on our Instagram page and maybe Facebook, but mostly on Instagram, and maybe on LinkedIn if you follow us on LinkedIn, which is a social that we need to explore a little bit more. And so, if you want to see the rover or something like that, or you have any other question? Giusto. Question on YouTube. What about the management group? It will be possible to apply one group or multiple ones. Okay. Okay. One question from YouTube said, it will be possible to apply for just one group or multiple groups. You can apply for multiple groups, but it's not so easy to be present and working like to give a contribute on more than one department or groups. But if you have a lot of free time, you can, of course. You can apply for one for more of one and then choose like in during the colloquio or the interview. Okay, during the interview or later. We don't like the team is not divided in like camere stagne. No English words tonight. So you can switch from one department to the other. Does recruitment have a deadline? Is possible, for example, to answer in December or in March? Okay. Yes, the recruitment has a deadline because we cannot afford to extend the recruitment phase to all the year because it's not so easy to manage new members in the team and also to give them the appropriate following. I don't know how to say it. So with some exception, the recruitment phase is mostly focused on this period of the year. There is the possibility that there will be another recruitment phase in March, depending on how the SISD competition goes and depending on how we are settled at the time. So and the form will like more information about the end of the form will be attached at the form. Okay, someone asked if it's possible to make the recruitment now and start working in the second semester. I don't know. Like, we have to. It's not. There's not defined bureaucracy for entering the team. So we have to evaluate case by case what are the needings of who wants to join now but start working on March. So it's not a yes, but it's not a no. Yes, you can be part of. Okay, someone asked if she can be part of management group if she's from aerospace engineer. The answer is yes. And the project manager Alessandro Meloni is from aerospace. I'm from aerospace engineer, and so yes, you can. Aerospace engineer are kind of gray zone in the team. Some does electronics, some does mechanics, some does management. So. Yes. Okay. Okay. No. Okay. So we can stop the YouTube live, and for the one on YouTube, thanks for watching, and have a great night.